Hello everyone and welcome to the next video in the series. This is a technical skills video on the topic of ordering rationals. And I'm going to cover this topic in three stages. First, we will talk about the case when the fractions that you're dealing with have the same numerators. So the top numbers are the same, but denominators or the bottom numbers are different. Then we will look at the case when the fractions have the same denominators, so the bottom numbers are the same, and the numerators are different, so the top numbers are different. And finally, we'll take a look at the case when both the top numbers, the numerators, and the bottom numbers or denominators are different. In the case of fractions with the same numerator, the fraction with the smallest denominator is the largest. To explain why this is the case, let's take a look at this problem. Let's say that we want to list the following fractions in descending order, so from largest to smallest. And these are 3/10, 3/4, and 3/5. As you notice, the top numbers are the same, they're all 3, but the bottom numbers are different. We have 10, 4, and 5. Now to explain why is it that we can order them following this rule that says the fraction with the smallest denominator is the largest. So in this case, 3/4 is the largest. Let's take a look at the diagrams that go with these three fractions. For 3/10, we divide a pie into 10 parts and take 3 parts. So this is the diagram that we get. For 3/4, we cut a pie into 4 parts and take 3 parts, and we end up with this kind of a diagram. And for 3/5, we divide a pie into 5 parts and take 3 parts, and we end up with this kind of a diagram. Now if you notice, with a denominator of 10, the pie gets cut into 10 parts, whereas with a denominator of 4, a pie gets cut into 4 parts. And because with 4, which is a smaller number, we cut the pie into fewer parts compared to 10, the size of one piece will be larger. So if you take a look at the size of 1/10, that would be one of these slices, and take a look at the size of 1/4, which is the size of one of these slices. You notice that 1/10 is much smaller than 1/4. And of course, if we have 3 pieces, each of which is a 10th, we'll end up with these 3 pieces. And here we also have 3 pieces, but each one is much bigger. We end up with this kind of a shape. And therefore you see that if the top numbers are the same, we have the same number of pieces, we can rely on the size of a piece to decide which fraction is larger than the other. The smaller the denominator, the fewer pieces you have overall, and the larger the size of a piece. So 3/4 is the largest, that's 4 with the smallest number in the denominator, 4, followed by 3/5, followed by 3/10. And therefore the answer to the problem that we are working on is 3/4, smallest denominator, this is the largest fraction, followed by 3/5, followed by 3/10. Okay, next we look at fractions with the same denominators. So the bottom numbers are the same, but the numerators or the top numbers are different. And in this case, the fraction with the largest numerator is the largest. And again, to explain how, let's take a look at a problem. Let's say that we want to arrange the following fractions in descending order. So again, from largest to smallest. Now this time we have the same denominators and the top numbers are different. And because the denominators are the same, each pie is cut into the same number of pieces overall. So this pie is cut into 10 pieces. And if we take a look at the diagram for 3/10, we notice that in 3/10 the pie is also cut into 10 pieces. And in 9/10, again, the pie is cut into 10 pieces. So this means that the size of one piece from any one of these pies is the same as the size of one piece from any other of these pies. And therefore, if the sizes of the pieces are all the same, we can take a look at the top number, which tells us how many pieces we get to order our fractions. The one with the largest numerator has more pieces, and therefore that one is the largest. That would be 9/10, followed by 7/10, and followed by 3/10. And I just realize that these diagrams, they look like cutting a lemon in half and looking at it from above. The color of it, I guess. Now my mouth is watering while I'm making a video, and I bet yours is too. Okay, the answer to the problem then is 9/10, followed by 7/10, and then 3/10. Okay, so that's how we work with fractions, how we order fractions that have the same denominators. The one with the largest numerator is the largest because it has the most number of pieces, and note that all the pieces are the same size. Alright, so the difficult case is when both the numerators and denominators are different. So as an example of that, suppose that we want to arrange the following fractions in descending order: 2/3, 1/2, and 3/4. Now I'm using small numbers to illustrate the ideas. Often with small numbers, what happens is that we can actually tell by just visualizing the sizes of these fractions. While there may be exceptions when it's difficult to tell, for the most part with small numbers it's not that difficult to tell. So if you imagine the size of 2/3, so in your imagination divide a pie into 3 parts and take 2 parts, and then the size of a half, you can tell that 2/3 is larger than half. And then you can also compare 3/4, the size of 3/4, with both 2/3 and 1/2 to determine the order. In fact, in this case, by just visualizing the sizes of these fractions, we can tell that 3/4 is the largest, followed by 2/3, followed by 1/2. Now, another thing that I would like to point out is that you may not rely on the relative sizes of the top numbers to order your fractions. So you may not argue that because 3 is larger than 2, then 3/4 is larger than 2/3, because we have 3 pieces, but here we have 2 pieces. Although in this particular problem that will happen to be the case, that 3/4 will be larger than 2/3 and then 1/2. Generally that's not the case, and generally that doesn't happen. And I will give you an example following this one to show you that it's possible to have a top number that's larger, but the whole fraction is smaller. But in this case, I chose these numbers because they're actually pretty nice to work with. They are very small, easy to draw, and therefore that was my selection for problem number 1 here. Now, if we take a look at the fractions, the diagrams for these 3 fractions, for 2/3 we take a pie and we divide it into 3 parts, of course, because the denominator is 3. We divide the pie into 3 parts. And then because the top number is 2, we take 2 pieces, and therefore we end up with this diagram. That's 2/3. For 1/2, we divide the pie into 2 parts, and then we take 1 part, and we end up with this diagram. And for 3/4, we divide the pie into 4 parts and take 3 parts, and we end up with this diagram. Okay, so one problem with relying on the top numbers is that the pieces are of different sizes. So here we do have 2 pieces, but and here we have 1 piece, but you can see that the 1 piece here has a much larger size compared to 1 piece over here. And that's what makes it difficult to compare these fractions size-wise when the top and the bottom numbers are different. The bottom numbers are different, the size of a piece is different, the top numbers are different, how many pieces you take is different. And so in order to order these fractions, you can either make the top numbers the same or you can make the bottom numbers the same. And if you make the top numbers the same, then you go by the first category that we covered in this video, and we said that if the top numbers are the same, the fraction with the smallest denominator is actually the largest. If you make the bottom numbers the same, then we go with the rule that for same denominators, the fraction with the largest numerator is the largest. It's much more common for people to make the denominators the same, and that also helps with addition and subtraction in the video coming up. Whereas making the top numbers the same does not really help with adding and subtracting, although for ordering it works pretty well. So here I will follow the usual approach and make the denominators the same. And in effect, what we are talking about then is that we are looking for a common denominator, a denominator that's the same for all three fractions. I suppose in that case, if you were going to make the top numbers the same, you could call them common numerators. And by the way, the process would be the same for making the top numbers the same or the bottom numbers the same. All right, so to make the denominators the same, one thing that we notice, and I will explain this in more detail soon, is that we can actually take these pies and divide each one into 12 parts. Now let me put the original cuts into the bottom diagrams. Like here we have 3 cuts corresponding to 2/3, and here we have 2 cuts corresponding to the 2 for 1/2, and here we have 4 parts corresponding to the 4 3/4. And now what we notice is that if we divide each of these 3 pieces into 4 parts, we end up with 12 pieces overall, and that gives us this diagram. And if we cut each of these 2 pieces into 6 parts each, we end up with 12 pieces in total. And if we cut each of these pieces into 3 parts each, we end up with 12 pieces in total. Now, how I came up with 12 is something I will tell you very shortly, actually. But for now, let's say that somehow we managed to work out the 12. So now instead of 3 pieces, we have a total of 12 pieces. And here instead of 2 pieces, we have a total of 12 pieces. For 3/4, the same. Instead of 4 pieces, now we have 12 pieces. Now, if you take a look at how many pieces we had here, we had 2 pieces. Each one was 1/3. And if we try to find out how many small pieces fit into 2/3, what we can do is we can divide 12 by 3. That gives us 4. And that tells us that in one piece up here, we can fit 4 small pieces from down here. So 4 small pieces fit into one of those. This we can figure out by dividing 12 by 3. When we divide 12 by 3, we are trying to see how many groups of 3 we can make, how many pieces of the size of 1/12 fit into one of the pieces up here. And we find 4. 12 divided by 3 is 4. And therefore there are 4 small pieces in one of those. And because we have 2 of these blue pieces and 4 small pieces fit in one, we multiply 4 by 2 to get 8. And so 2/3 and 8/12 are the same. Once again, the process is we divide 12 by 3 to get 4. That means 4 small pieces fit into one of those. And then we multiply the 4 by 2 to get 8, because we have 2 of these, and 4 small pieces fit in one. For 2 we get 4 times 2, and that's 8. So again, 12 divided by 3, 4. 4 times 2, 8. We can do the same for 1/2 and its equivalent fraction. And here we have, if we divide 12 by 2, we get 6. And that means that 6 pieces fit into 6 of these small pieces fit into one of the pieces on top here. And because we have only one piece at the top, we'll have 6 of the small pieces, and we get 6/12. And you notice how the approach that I just told you about with 2/3 and 8/12 also works here. If I take 12 and divide it by 2, I get 6. Then 6 times 1 is 6. For the next one, we would divide 12 by 4 to get 3. And that means that 3 pieces, 3 small pieces, fit into one of the ones above. And because we have 3 yellow pieces, we multiply this 3 by 3 to get a total of 9. So we have 9/12. And once again, in all cases, once we have the 12, assuming we somehow managed to figure out that 12 works, that we can divide each of these pies into 12 parts, then we divide the 12 by the denominator of each of these fractions, take the answer and multiply by the top. 12 divided by 3, 4. 4 times 2, 8. 12 divided by 2, 6. 6 times 1, 6. 12 divided by 4, 3. 3 times 3, 9. Now that all of the fractions have the same denominators, one piece from any one of them has the same size as one piece from any other one, and therefore the one with the maximum number of pieces is the largest. That would be 9/12, and then followed by 8/12, and then followed by 6/12. Okay, now comes the big question: how do we find 12? What you noticed is that the number that I picked, the 12 in this case, had this kind of property that it was divisible by all of the denominators at the top. 12 is divisible by 3, it's divisible by 2, and it's also divisible by 4. And that becomes the idea. What you need to do is try to find a number that's divisible by 3, 2, and 4 by all of your denominators. And how do you go about finding that number? Well, my recommendation is that first you should think about it. Like, try to see if you can just come up with 12. For small numbers, and if you have a good control of the multiplication table, that shouldn't be a problem. For 3, 2, and 4, it should take you between 5 to maybe 10 seconds to find 12. If you're really good with the times table, you would find it almost instantly. And if that doesn't work, if the numbers are not so small or so easy to work with, then in case your denominators have nothing in common, you can multiply them. Like, if I was working with two fractions and the denominators were 3 and 5, there is nothing common to 3 and 5 in the sense that whatever goes into 3 doesn't go into 5, and whatever goes into 5 doesn't go into 3. In that case, you can just multiply the denominators, and you get 15 as the common denominator, and it's actually the least common denominator. But if the numbers have something in common, that's not a good approach. You should not multiply your denominators, and I will show you very soon that if you do that, you can end up with very large numbers to work with, even if you start with small numbers. So that's not a good approach. Again, you only multiply your denominators if they have absolutely nothing in common. In this case, for example, if I multiplied the denominators, I would end up with 3 times 2, 6, times 4, 24. Now, in this case, it's not that bad. 24 is not that large, but as you will see in an example coming up, it's usually not the case. Usually you'll end up with a very large number. Keep in mind that 3, 2, and 4 are pretty much the smallest numbers we can use for denominators. Okay, so suppose that you cannot really think of any number that's divisible by 3, 2, and 4. And because 2 and 4 have a 2 in common, I would not want to multiply these denominators together. So how do we go about finding the least common denominator, which is 12? What we'll do is we convert our fractions into their equivalent fractions with the same denominators. And here's how we go about doing that. Okay, so here are the fractions: 2/3, 1/2, and 3/4. Okay, so we are going to use primes, and therefore let me list them. Here there are 2, 3, 5, 7, 11, 13, 17, 19, and so on. And then what we do is we draw a vertical line, and on the right side of it, we list or we put down the denominators of the three fractions: 3, 2, and 4. Now, we take a look at the first prime, 2, and we ask the following question: does 2, the prime number 2, go evenly into any one of these three numbers? It doesn't have to go into all three. So long as it goes into even 1, we use it. And so 2 does not go into 3 evenly, but it does go into 2 and 4. And therefore we write the 2 down. We write the 2 down on the left side of the vertical line. And then any of the numbers 3, 2, 4 that are divisible by 2, we divide them by 2. Otherwise, we just leave them alone. So 3 is not divisible by 2, and therefore we don't touch 3. We just write it down. 2 is divisible by 2, and 2 divided by 2 is 1, so we write down 1. And 4 is divisible by 2. In fact, 4 divided by 2 is 2, and we write down 2. So any of the numbers that were divisible by 2, we divided them by 2 and wrote the results down. Now we go back to the prime number 2, and we ask the same question again for the new values that we have. Does 2 go into any one of these values? And the answer is yes, it does go into this 2. And therefore we use the prime number 2 again. We write it down on the left side of the vertical line. And any of these numbers that are divisible by 2, we divide them by 2 and write the answer down. Now 3 is not divisible by 2, and therefore we don't change 3. Anything that's 1 stays 1. And 2 divided by 2 is 1. Okay, we repeat the cycle. The prime number 2 can no longer be used because none of these numbers is divisible by 2. We move on to the next prime, which is 3, and we notice that we can use 3. We write the prime number 3 down, and any one of these 3 numbers that are divisible by 3, we divide them by 3 and write it down. So we get 1, 1, 1. Once you get to all 1s, then you're pretty much done with this process, which is called prime factorization. And what we do is we take the prime numbers that have come up, 2, 2, and 3, and multiply them. And that is guaranteed to give you the least common denominator, 12. Now, of course, 12 is not the only common denominator that you can use. If a value works, such as 12, then guaranteed twice that value will work as well, 3 times that value will work as well, and so on. But 12 is the smallest common denominator that we can find, and therefore we refer to it as the least common denominator. This approach will always give you the least common denominator. But my recommendation is that this approach should be used in extreme cases, like if you really get stuck and you cannot work out a least common denominator or a common denominator that's reasonable, then you follow this approach. For 3, 2, and 4, in fact, if you work with 24, which is twice the least common denominator, twice 12, it's still a good number, it's not that bad. So basically, if my recommendation is try to think about it and try to come up with a number that's divisible by 3, 2, and 4. Even if you don't find 12 and you find the next least common denominator, which is 24, that one is still a good one to use. But if you start if you find that your number is getting large, then perhaps it's a good idea to try this approach to see if you can find basically the smallest number that you can work with. Alright, so the process is we list our fractions that are given, and once we find the 12, then we change the denominators to 12. Now we follow the same process that we talked about earlier. 12 divided by 3, 4. 4 times 2, 8. Then 12 divided by 2, 6. 6 times 1, 6. And 12 divided by 4, 3. 3 times 3, 9. And we end up with the equivalent fractions that have the same denominators. Okay, now because denominators are the same, all the pies are cut into the same number of pieces overall, and therefore one piece of the pie from any one of these fractions has the same size as one piece of the pie from any other one of these fractions. And therefore the one with the most number of pieces is the largest. That would be 9/12. Now keep in mind that you need to arrange your original fractions in descending order, and therefore 9/12 corresponds to 3/4. That one will appear first, followed by 8/12, which is 2/3. That one appears next, followed by 6/12, which is 1/2. That's the smallest, and that one is last. Okay, time to take a look at some other problems, some other examples. This problem says list the following fractions in descending order. And this time we have pretty much the same fractions that we worked with in the previous problem, but this time they are negative. On the topic of the location of the negative sign, all of these fractions, whether you put the negative sign on the side or on the top or the bottom, it's the same thing. So for example, with negative 1/2, whether you put the negative sign on the top or the bottom or on the side, it's all the same value. The first one, negative divided by positive, is negative, and 1/2 is 0.5 if you wanted to think decimals. So we are talking about negative 0.5. With the second one, we have positive divided by negative, which is negative, and again the size of it is 1/2, which is 0.5. So again we have negative 0.5. And here we have a negative number whose size is 1/2. And that's again negative 0.5. So all three of these are negative 0.5, and therefore it makes no difference whether you put the negative sign on the top, the bottom, or on the side. Now the bottom, although there is no difference in terms of size, when we work with fractions we usually prefer not to have negative denominators. Very difficult to interpret and work with. So we usually put the negative sign on the top. And for final answers, we prefer to have the negative sign on the side, so that so that the reader knows very quickly that we are talking about a negative number, and the size of it follows the negative sign. Okay, let me get rid of these fractions. And now to solve the problem, I'll start by putting the negative signs on the side so that they're not so distracting. So I'll repeat the problem with the negative signs, the list with the negative signs on the left side. And again, now this is the same as the top problem. We have to make the denominators the same, and we still have to find the least common denominator, which is 12. The only difference between this problem and the top one is that the values are negative. But in terms of size, we worked with them in the same way. So we find 12, and then 12 divided by 3, 4. 4 times 2, 8. And then we have 12 divided by 2, 6, times 1, 6. And we have 12 divided by 4, 3, times 3, 9. Now, of course, in terms of size, 9/12 is the largest. But keep in mind that with negative numbers, the one with the larger size is actually the smaller of the rest, compared to other ones. And so the one with the smallest numerator would be the largest one, and therefore negative 6/12 is the largest, which corresponds to negative 1/2, or the original form of it, negative 1/2. That's followed by negative 8/12, which corresponds to negative 2/3. And the smallest one is negative 9/12, which corresponds to negative 3/4, which came from 3/4. So you see, I have ordered the fractions in the form that they were given. Negative 1/2, followed by negative 2/3, followed by 3/4. Okay, the next problem. Now here we have 3/8 and 2/3. And for the least common denominator for this problem, this is what I was talking about. In case your denominators have nothing in common, like 8 and 3, 2 goes into 8 but not into 3, 4 goes into 8 but it doesn't go into 3, and 8 goes into 8 but it doesn't go into 3. And as far as 3 goes, only 3 goes into 3, and 3 doesn't go into 8. So there is nothing, no factors that are common to 8 and 3. In that case, even if you use the chart, you'll end up with a value that's the product of the denominators. So you might as well just multiply them and put down 24. Now 24 divided by 8 is 3, and 3 times 3 is 9. And 24 divided by 3 is 8, and 8 times 2 is 16. And now we can tell that 16/24 is larger than 9/24, and therefore 2/3 is the larger of the two fractions. The list, in descending order, is 2/3 followed by 3/8. Okay, now we've got these three fractions to work with. And what we need right away is the least common denominator, or at least a common denominator that's not too large. Now in this case there is a lot of commonalities. 12 and 16 have 2 in common, 4 in common. 6 and 18 have 2, 4, 8 in common. 12 and 8 have 4 in common as well as 2 in common. And when there are these commonalities, it would be a big mistake to multiply your denominators, because you can usually work with a much smaller number compared to the one that you get if you multiply your denominators. Now let's first find the least common denominator, and then we will compare that to the situation where to the number that we would get if we multiplied our denominators. So to begin, we list the primes, and then we put down the vertical line, and we put down our denominators, which are 12, 16, and 8. Then we start with the first prime, which is 2, and we ask ourselves, does 2 go evenly into any one of these numbers? And the answer is yes. It actually, in this case, it goes into all 3 of them. It doesn't have to. So long as it goes into even 1, we use it. And we put the 2, the prime number 2 here, and divide any of 12, 16, and 8 that are divisible by 2. We divide them by 2 and write the answers down. So 12 divided by 2 is 6, 16 divided by 2 is 8, and 8 divided by 2 is 4. Then we go back to prime number 2 and ask ourselves, can we use 2 again? And the answer is yes. 6, 8, and 4 are all divisible by 2. So we divide them by 2 again and put down 3, 4, and 2. So 6 divided by 2 is 3, 8 divided by 2 is 4, and 4 divided by 2 is 2. We can use 2 again because although it doesn't work for 3, it does work for 4 and 2. And keep in mind that it doesn't have to go into all of the numbers. So long as it goes into even 1, you use it. So we put 2 down again and divide anything that's divisible by 2, we divide it by 2. Anything that's not divisible by 2, like 3, we leave it alone. And you notice that 2 can be used one more time. So we put it down, divide anything that's divisible by 2, and write the answers, which are 3, 1, 1. Now 2 doesn't work anymore. So we move on to the next prime, which is 3. And we notice that we can use 3 because this 3 is divisible by it. We write 3 down, and then divide anything that's divisible by 3, we divide by 3 and write down the results. Once we get to 1, 1, 1, everything is 1, we're done. Now we take all of these primes that have shown up on the left side and we multiply them, and again this is guaranteed to give you the least common denominator, which is the smallest common denominator that you can use, in this case 48. Okay, now we put down 48 as the common denominator we want to work with, and then in sequence we divide by the bottom, multiply by the top. 48 divided by 12 is 4, 4 times 5, 20. 48 divided by 16 is 3, and 3 times 7 is 21. 48 divided by 8 is 6, and 6 times 3 is 18. You notice how many times I just used the times table in both going forward and backward. Divide 48 by 12 and then multiply by 5. So that's 2. And then divide 48 by 16, multiply by 7. Now 4. Divide 48 by 8 and multiply by 3. 6 times in just changing the fractions that are given to their equivalent fractions with the same denominators. Okay, now we can list the original fractions in descending order with the same denominators and all of them being positive. The one with the largest number of pieces. So here 21 is the largest. That would be 7/16. And then the next one would be 5/12. And the last one is 18/48, which is 3/8. Okay, so in this case as well, it appears that the one with the largest numerator appeared to be the largest, followed by the next largest numerator and then the next one. But take a look at the previous problem, and you notice that when we ordered them, the one with the smaller numerator happened to be the larger of the two. So you cannot compare the numerators unless the denominators are the same. Alright, so the next case now is, oh, and by the way, before I continue, let me show you what would happen if instead of finding the least common denominator, 48, if you multiplied your denominators. So in this case, let me open the calculator. In this case, we have 16, and multiplied by 12, and then multiplied by 8. And you notice that I get 1536. So imagine, instead of 48 down here, if we used 1536, and instead of saying 48 divided by 12, which is 4, we would have to say 1536 divided by 12. This is inefficient. Alright, so what happens if you have mixed numbers and whole numbers in the mix? We want to list the following fractions in descending order: 2/3, 5/2, 2 1/4, and 2. Now again, with small numbers, it's not that difficult to just visualize them and tell. And I am using small numbers just so that we can illustrate ideas. But when the numbers get larger and more complicated, of course, visualization may not work very well. But it's a skill that I recommend that you should have. At least with common fractions, which we use relatively commonly in dealing with problems. Okay, the idea here is that there are two approaches. You can either convert all of your improper fractions to mixed numbers and then compare, or you can convert all of your mixed numbers and whole numbers to improper fractions and then compare. And we're going to take a look at both approaches here. So solution, the first one says that you can convert all your mixed numbers into improper fractions and then compare. And that should, of course, say all your mixed numbers and any natural numbers. So in this case, 2/3, we're going to leave it alone. 5/2, we're going to leave that one alone. For 2 1/4, we multiply 4 by 2, 8, plus 1, 9. And for 2, which is a natural number, it goes over 1. So 2 whole things is the same as 2 ones. Now we find the least common denominator. Now it's best to think about it. Again, 3, 2, 4, and 1. Now here's a life hack. There is another approach for finding the least common denominator, which works very well for smaller numbers. What you do is you take the largest denominator that you have, in this case 4, and see if you can use that one. And in this case 4 doesn't work because 4 is not divisible by 3. If it doesn't work, then double it up and see if you can use that. 4 times 2 is 8, and 8 doesn't work because 8 is not divisible by 3. So multiply it by 3 and see if that works. 4 times 3 is 12, and 12 is divisible by 3, it's divisible by 2, and it's divisible by 4. And of course anything is divisible by 1. So once again, take the largest denominator, see if you can use that. If not, multiply it by 2, see if you can use that. If not, multiply it by 3 and see if you can use that. And keep doing that until you'll find a value that works. Okay, so we find 12 and we write 12 down as our least common denominator. Then in sequence we divide by the bottom, multiply by the top. Fraction 1, 12 divided by 3, 4. 4 times 2, 8. Fraction 2, 12 divided by 2, 6. 6 times 5, 30. Fraction 3, 12 divided by 4, 3. 3 times 9, 27. And the last fraction, 12 divided by 1, 12, times 2, 24. And now we can order them in descending order. The one with the largest numerator has the most pieces. So 5/2, followed by 2 1/4, followed by 2, followed by 2/3. And there we have it. And actually my 9/4 should have been 2 1/4 because we are ordering the original fractions the way they were given. So let me actually fix that so there is no confusion here. So we have a 2 and 1/4. Okay. Now there is an alternative approach, as I mentioned. With the alternative approach, what we do is we convert all of our improper fractions and also improper fractions into mixed numbers and natural numbers, and then we compare them. So in the case of fractions that are given, 2/3 is proper, stays as it is. 5/2, we're going to change that to 2 1/2. You can do this by dividing 5 by 2 and taking a look at the quotient and the remainder. Okay, now it's pretty easy to compare them. As I said, the fractions are small in size, so we can tell that 2.5 is the largest one, followed by 2.25, then 2, and then 2/3. If the fractions are not so easy to tell at a glance, then you have to find, then you argue that because 2.5, 2.25, and 2 have 2 whole parts, but 2/3 doesn't have that, then 2/3 is not going to be the largest of them. And 2, of course, is just the 2, whereas 2.25 as well as 2.5 are more than 2 because they have additional fractional parts. So for these two, we can find the least common denominator. Again, in this case, it's pretty easy to tell, but if it's not easy to tell, then you can find the least common denominator for these two and change the top numbers accordingly. So least common denominator is 4, then 4 divided by 2, 2, 2 times 1, 2. 4 divided by 4, 1, 1 times 1, 1. And now we can say that 2.25 is the largest of them. And therefore 5/2 appears first, followed by, again, we have 9/4. You know, this comes from copying and pasting. Okay, let me change it to 2 1/4. There we have it, followed by 2, and then followed by 2/3. Okay everyone, thank you so much for watching this video, and I'll see you next in the video on addition and subtraction of rational numbers. Now one quick comment. The process for finding the least common denominator is a big one when we talk about addition and subtraction. And if you know how to find your least common denominator, then addition and subtraction is not difficult at all. See you in the next video.